Okay, in order to help you understand exactly what distributive property is all about, we put together this little presentation based on something most of you can relate to, which is Happy Meals. For those of you that can't see at home, what I'm trying to do is move the recording so you can see the meals. We came up with 4 different meals for you. We've got the Fry Lover meal. You get a Big Mac, two fries, and a drink.
Yes, sir.
We've got the Share meal. You get a large chicken nugget, 1 fry to share, and 2 drinks. Then we've got the Family meal. We've got 2 Big Macs. You share a fry, and then everybody gets a drink. And we have the Chicken Share meal. 2 chicken nuggets, again, share the fry, and 2 drinks. How many of you have ever gone to McDonald's?
Me.
Okay, almost everybody. I see 2 hands not up.
Wow.
When you go, and I don't know if you've ever experienced this, unfortunately, especially if you go through drive-through, you may not end up with everything that you ordered.
Oh, yeah.
So, I actually recommend counting and making sure you have your entire order, especially if you're doing like a whole family deal, because a lot of times what happens is you'll order this combo meal and it doesn't come out correctly. So, what we're doing today is actually just doing combo meals. Let's take a look at what I mean by that. So, for example, if I drive through the drive-through and say, okay, I'd like 2 number ones. When I count, I should be able to know how much I have based on the fact that each meal, both of them, our 2 combos, have 1 burger, 2 fries, and 1 drink. Does everybody agree with that?
Yep.
So here's how distributive property works. What I'm saying is I have 2 sets of this entire deal. So I'm going to find inside my meal 2 of those 1 burgers, 2 of the 2 fries, and 2 of the 1 drink. I do highly recommend drawing these arrows anytime you're doing distributive property, guys. It's going to help you keep straight everything that you need to do within this problem. Because literally all I'm doing is distributing this 2 out to each of those individual things. So because I have 2 combo meals and each of those has 1 burger, how many burgers should I have in my bag as I drive away? 2 burgers. Everybody okay with that? How many fries should I have?
4.
Is everybody okay with that? Everyone understands where that number came from?
Yep.
How many drinks should I have?
2.
2. So as I drive away with 2 combo meal number ones, I bought 2 burgers, 4 fries, and 2 drinks. Make sense?
Yes, sir.
Okay? So let's look at our next one. Now I want to get 3 combo meals of number 2. So I want 3 of combo meal number 2. Combo meal number 2 is the one that came with 1 chicken nugget, 1 fry, and 2 drinks. This is my sharing meal. So we're going to rewrite that. So it's going to be 3 times 1 nugget plus 1 fry plus 2 drinks. I'm rewriting it so I can draw my arrows. Now I've got room to do that. So in the end, what do I end up with? I have 3 of the 1 nugget, giving me how many nuggets? 3 nuggets. I've got 3 of the 1 fry, giving me how many fries? 3 fries. And I have 3 of the double drinks, giving me 6 drinks.
Wow.
Does everybody understand it? Yeah. Makes sense, right? So in the end, what did I end up buying? As I drive away, I should have 3 nuggets, 3 fries, and 6 drinks. Everybody okay with that one? Okay, our next one. Now we're going to get 2 of combo meal number 3. So now we're on our share meal. So I'm getting 2 combo meals. Each combo meal has 2 burgers, 1 fry, and 2 drinks. Everybody see that? So on this one, I've got 2 combo meals, 2 burgers, 1 fry, 2 drinks. So I need to distribute, using my arrow, to each of the individual items inside of the bag. So two burgers means I end up with how many burgers?
4 burgers.
4 burgers. 2 of 1 fry means I get
3 fries. No, 4 twinks. No. 2 fries. 4.
2 of 1 fry.
What?
2 orders of 1 fry.
That's 2. Wait, what?
Yeah, Devin was saying 3. 2 orders of 2 drinks. 4 drinks. So in the end, I bought 4 burgers, 2 fries, and 4 drinks. Our last one. Now we're going to go for that chicken shear meal. So we've got 3 combos of the number 4. So I have 3 combos. In each combo, I'm getting 2 nuggets, 1 fry, and 2 drinks, correct? Doesn't have my picture, I want to make sure. Okay, so as we write that, I've got 3 combos with 2 nuggets, 1 fry, and 2 drinks. I need to now distribute that 3 to all of my inside terms. So 3 times 2 nuggets means I end up with 6 nuggets. 3 times 1 fry means I have 3 fries. And 3 times the 2 drinks means 6 drinks.
Oh, no, Devin.
I thought you were adding like 3 plus 2. And then 2 plus 1. And then 3 plus 2.
I'm glad it only took 4 examples for you to figure it out, Devin.
I'm great.
Okay, so I ended up buying 6 nuggets. We have 3 fries and 6 drinks. Yes. We wanted to make sure you were hungry. Now, let me just throw this side now because I've heard several of you ask about a field trip. If I can talk Miss Caruana into it again, we have actually in the past, when we get to our statistics unit, done a class field trip to Burger King at the food court.
Mr. Griffith told me about
Yep.
it.
And we have everybody buy a large French fry, and we count them, and then we eat them, and then we come back and we collect our data, and we can see the range, mean, median, and most for how many fries you get in a large fry.
Do you get large fries for yourself?
Yeah. Yeah, guys. An experiment like that only works if you have larger numbers. So we're not going to all walk down there and I'm going to buy a fry and eat it for you. We'll each get to buy your own fry, and then we'll get to go from there. So we'll see. No promises.
Wait, that's smart. So we just buy a fry that you bought for us?
No. Okay, next one. 3 of combo meal number 1. So we're back to our first combo meal. This is our fry lover one. So I'm getting 3 combo meals. Each one has 1 burger, sorry. 1 burger, 2 fries, and a drink. So using our distributive property, 3 times 1 burger plus 2 fries plus 1 drink. I need to distribute that to everything on the inside, meaning I ended up with 3 burgers, 6 fries, and 3 drinks. So what did I end up buying?
3 burgers.
3 burgers,
6 fries.
6 fries,
And 3 drinks.
and 3 drinks. Is this making sense to everybody?
Yes.
Okay? So the whole idea was get the combo meals, because you guys have seen those before, give you a real life interpretation for what this means. So now it should make sense exactly what we're doing. What I'm saying is I have 3 sets of this 1 combo meal. Make sense?
How
Ezzy?
big are the chicken nuggets?
It looked like they were 5-piece ones.
What? That's not a combo? So are
Okay.
Are they like
Now, quick ELA lesson. What does it mean to distribute something?
To separate.
to give?
To give out, right? So distribute means to
Give out.
give out.
Yeah, basically dividing the
I don't want to say divide because it's giving it out to make sure that it goes to everybody, right? So when we use distributive property, we give out the number or the variable, and that's a key thing, guys. It may be a variable on the outside of the parentheses. To each term on the inside. So whatever's on the outside is going to be distributed or given out to everything on the inside. We use distributive property to find, you guys aren't going to guess this one, so I'll just put it up here, equivalent expressions.
Dang it.
Equivalent expressions. In other words, ones that are equal to each other. It is useful, we need to multiply a group of, I'm going to use terms, because it could be numbers, but it could also be variables. So each of those is considered a term. Now there's a number of variable. The term is one that covers everything. So the number of terms being added or subtracted, and that's another key, guys. In this, I could add or subtract. It won't only be addition on the inside. It will not be multiplication or division on the inside. Distributive property works only with addition and subtraction. Okay? So, an example with the arrows, kind of what we've already done. The first thing I'm going to do is distribute using the arrows. In other words, here's my key number on the outside. That is the one that's being distributed or given out to everything on the inside. How do I do that? By just drawing those little arrows. That's telling me, take that 2, multiply it by each of the inside terms. Sometimes, guys, you may see 2, 3, 4 multiple terms inside. It would be distributed to everything on the inside of the parentheses. So I could now rewrite this. What I'm doing is I'm taking that 2 times the 5. Whatever this is comes straight down, in this case addition. And then I'm doing that 2 times the 3x. So, Devin, I think I already heard you say, what's 2 times 5? 10. What's 2 times 3x? 6x. Last step. Simplify if possible. In other words, this will normally only happen if I've got multiple terms inside, more than 2. Sometimes you'll end up with things that can be together. So if I had 2 numbers, I could put those together now. If I had 2 sets with the same variable, I could put those together now. But you're going to simplify. In this case, I have a number and a variable, so I can't simplify any further than that. So a model, let's model what this looks like. What we have just done is I've taken this little piece right here, 5 plus 3x, which you guys should all know how to model by now. They're written side by side. And I'm saying I have 2 sets of this. So I draw a second set of them. And now I can put those together. So if I do 5 and 5, what do I get? 10. 3x and 3x I get. Does that make sense? Literally, what I'm saying in distributive property is I'm saying I've got 2 sets of this. So I have 2 sets of this being put together. Make sense? Good. I love how you get it too. Makes me happy.
I never get anything. I never got anything.
You've been doing well all year, Ezzy.
I never got anything in my last year's class because teacher was horrible.
Teachers make a difference. I do believe that. Okay, again, distributive property, guys. All I'm doing is taking that outside term, distributing to everything on the inside. Okay, quiet down. So I've got my 2 times 5, which is 10, plus 2 times 3x is 6x. I can also rewrite that if it makes you feel better. I'm doing that 2 times 5 plus 2 times 3x. What about if I have subtraction? Does it change anything? The answer is no. I'm still drawing my arrows to each of those inside terms. I'm still writing it. 3 times x minus 3 times 4. So 3 times x is 3x, The sign comes straight down. 3 times 4 is 12.
I don't know, so where'd you get a J?
I'm sorry?
A J. You got 2 J's.
No, that is
That's
an
my
arrow
arrow
sign.
showing I'm bringing down the negative minus.
It's
sign.
an arrow.
What about the one next to the A?
Oh, that was just my board fritzing out as I drew the parenthesis.
The only thing my teacher taught me is to not speak.
Okay, so hopefully you guys have enough practice. I'm going to go ahead and give you, we'll give you 7 minutes, 8 problems. I want you guys to work through this as a table. You may talk with your partners if you want. Go. I will say I'm very, very disappointed in the number of you not writing the arrows. Guys, it's a very, very simple thing that will help clarify everything on this. Okay? If I rewrite my arrows, then it becomes super easy because I can physically see exactly what all I'm doing. So on the first one, it's just 6 times x, which would be 6x. Whatever this is, guys, comes straight down. So it's going to be a plus. 6 times 5 is 30. It should be this easy. If you'll draw the arrows, it is quite literally 2 times r is 2r. This comes down minus 2 times 4, 8. That was my water bottle. 4 times x, 4x. This comes straight down, plus 4 times 8, 32. It doesn't matter if it's on the other side. Now, mathematically, we normally want it on the front side. Normally, if you see it on this, it's like a trick question trying to mess you up. So just be careful of that. But it really doesn't change anything. I'm still distributing to the inside. Quick note on this. If it's on the back side, don't reverse your order. It's still going to be the same order as it's written on the inside. So what's n times n?
N to the second power.
N to the second power. My sign still comes straight down. N times 6. 6n. Now, another quick side note, guys. Another quick side note. Remember, coefficient always comes before the variable. So don't go n times 6 and write it as n6. We reverse that. Coefficient will always come before our variable. Make sense? Okay, our next one. Again, if you'll do the arrows, this is super easy. 7 times 2x, 14x. The sign comes down. 7 times 10, 70. 56x. Sign comes down. It's going to be subtract. 8 times 2, 16. Guys, please be quiet. 3 times 5, 15. Sign comes down. 3 times y. Do not reverse that just because it's got a variable. We do not have the commutative property of subtraction. If you made it 3y minus 15, you're wrong. Again, does not matter if it's on the front or the back side. I follow the order from the inside. 8 times 2 is 16. Sign comes down. 8 times 2, 8 times n is 8n. Questions?
No, sir. None wrong.
Yes, Devin. Oh, yeah, I forgot to write that because I studied it. I forgot to write it. Thank you. Okay. Turn the page. All right, take it back. I want everybody to go ahead and get out a blank piece of paper.
What do you want from me?
Uh-oh. Blank piece of paper. So here's what we're going to do. I'm going to give you a piece, and you're going to have a missing number that you need to fill in. The missing number is your question mark, so I want to know what that is. But our next step is I also want to know what it equals. So you're only going to have, it depends on the problem, 30 seconds to 1 minute. in order to do it. And then we'll go over the answers on each one individually together. So our first one, I'll give you 45 seconds. Go ahead and start now. So what goes where my question mark is? 23. Hopefully you guys were all able to get that. What is the total?
184.
240.
I said that.
Oh, 30. Oh, 30.
I'm an idiot.
Now, guys, listen up. Here's the key on this. Normally what we're going to do on distributive property, guys, is try to make it so we can do mental math. That is really the biggest idea behind distributive property, is saying I have this common factor between these numbers that I can use. Now what can I do to make the math easier so I can do mental math? So this one, they kind of did the opposite. They took a number that would have been easier to do, which is what I did. I actually just combined that and said that's 8 times 30. Because 8 times 3 is 24 and put a 0 at the end. Instead of saying 8 times 7 is 56, plus 8 times 23 is 160, 184, which if I add those two up, I'd get 240 anyway. Normally what you're going to do is take a number that's harder to do and break it into two numbers that are easier. So you'll see that as we continue on through. So our next one. Now, when I say use distributive property, I want you to take this and then write it so that you can use distributive property. In other words, this is the expanded form. Show me what we distributed it from. So because we're doing both, I can see who all got this one. What did it look like before I distributed? This would have been 5 times 8 plus 2. So that's your first part. And then this is actually 5 times 10 or 50. From this side, it would have been 40 plus 10. Either way of solving that one would work. Okay, now you guys have the idea. Go ahead and distribute this and then evaluate. This one's a little harder. I'll give you a 40. I'll bet I did this one differently than most of you. So what I did 8 times 30 minus 1. It gave me 8 times 30 minus 8 times 1. So all I did was take 240, subtract 8 to get 232. Now, my guess is most of you probably with 8 times 20 plus 9. So you did the 8 times 20 plus 8 times 9. So you had the 160, added the 72, and you'd still get to the same answer. Here's the difference, guys. For my math, very simple because I'm using zeros and ones, right? 240 minus 8. This one, I'm adding a 6 and a 7, which is one that even a lot of 6th graders still have issues with. I see a lot of fingers when you start adding 6s, 7s, and 8s. So this one is a little bit more difficult, but you'll get the same answer, which is one of the cool things on this. There's not necessarily one right answer. It's how are you seeing the numbers. But what I want to show you is get used to thinking about subtracting as well as adding. Just naturally, because of the way we are taught, most of you will always think addition before you think subtraction. Try to get to the point where you're much more fluid going to both of them. Realize they are both equally viable. Okay, our next one. Again, fill in my missing number. This was easy, 30 seconds.
I know.
Should have been very easy. The number I see on the outside is 3. 3 times 2 is 6.
I got 6 too.
Our next one. Numbers aren't too bad. I'll give you 30 seconds. The number was 3. Then I've got 120 plus 12. 132. Next one. Again, distributed property. Show me what it looked like before I distributed. Okay, what did it look like before I distributed? 4 times 34 minus 24, which would have been 4 times 10 or 40. Number 7. Same deal. One thing to do. This will take you about 15 seconds, and that's all writing. Question mark was a 1. So I did 180. Guys, come on. Please, once I start talking, you need to stop.
Yes, sir.
180 plus a 6 gave me 186.
Yes, sir.
Number 8. Another question mark 1. Question mark. 3. Inside. 4 minus 2 is 2. 3 times 2 is 6. We did. Okay. Again, distributive property. So figure out how to break 58 up, guys. Quick question. How'd you guys break this one?
50 and 8.
50 and 8? So 3 times 50 plus 8 gave us 3 times 50 plus 3 times 8, or 150 and 24 for 174. Anybody do it different?
Yeah, no. I did.
Good. That's the way I would have done it. Guys, please don't forget the ability to subtract. 3 times 60 minus 3 times 2. So it was just 180 minus 6, or 174. Okay, next one. We got 3 to go. Again, show me what it looked like before. This one should have been super easy, so that's 3 times 25 plus 100. What it should have looked like. Or 3 times 125, 375.
No, I got 399,999.
You're wrong.
I got 375.
Okay. Ooh, here's a tricky one. I'll give you a full minute on this one. So, what was the question mark?
Ooh, 90.
90. So if I break this out, guys, 400s is 400. 490s is 360. 47s is 28. Put all those together, 788. Now, guys, this is another one. Personally, I would have done 200 minus 3, which would have given me 800 minus 12, or 788. But you can do it either way. Last one. Again, find our missing number.
Easy answer.
So, see if, Devin, what's our question mark?
I was saying
Oh my! Oh my! Wow! It's subtraction!
Okay. Just for the record, since this is being recorded, I was trying to give Devin a chance to shine. I really did not expect a major face flop on that one. My number was 38. I need some number I subtracted 2 from. 5 minus 2 is not... Oh, hopefully didn't pick that up. You're right, yes, 40. 200 minus 10 gave us 190. Guys, quiet. Settle down. Glad we were able to have some fun on that. Guys, you feeling okay on these?
yeah.
Make sense? Literally, all I'm doing, taking numbers, splitting them up, either subtraction or addition, to make your math easier. That's what the whole purpose is. Let's look at your homework.
I didn't think it was more.
Guys, come on, please. Couple quick notes. Again, don't be thrown off if I put it at the end. It's the same thing. Make sure you follow the order on the inside of the parentheses. Do not get thrown off by fractions or decimals. You know how to do that. Do your arrows. It's 1/2 of R, 1/2 of 10. 12.1 times 4, 12.1 times Z. Very easy. On the bottom, we got some word problems. The word problems, you're going to need to look here to figure out what the costs are, but they're all right there on the table for you. Go turn it over. Go to the last page. Whoops.
Yoshi.
It's on the same one. You have done these before. Here is our start. Guys, quiet down. William. Same deal. Make sure you're showing your work. Guys, this is so easy if you will just draw the arrows. I mean, maybe it seems too easy for you, but the easy things sometimes make it better. 4 times 2x gives me 8x. The sign comes straight down, plus 4 times 1 is 4. I find the one that has that, and I color it in. You've done these before, okay? Then I'm going to do the next one. You're going to go around the maze. I threw a unicorn in there just so you guys could have some enjoyment, but your finish is actually down here. Questions?